हेलो बच्चों, वेलकम टू गेट वाला. हाउ आर यू guys? Please tell me in the chat box that audio and video are clear. Audio video is clear. We are good to start. So in this session we are going to discuss around 20 questions, 20 beautiful questions to revise your digital electronics. Okay, some of the question belongs to mux, some of the question belong to sequential circuit, some of the question belong to combinational circuit. So the questions are from every concepts which are important for GATE 2026 examination. Okay, and today only at 7 p.m. there is another session where we are going to discuss around 25 beautifully framed questions, and there are some tougher questions also, some very standard questions also at 7 p.m. on GATE Wallah ECE channel. Okay, so in this session we are going to discuss around 20 questions, and in that session also we are going to discuss around 20-25 questions. So total we are going to discuss around 40-45 questions, and that will cover your overall entire syllabus of the digital electronics, and these all topics are very important for GATE 2026. So are you guys ready? Please tell me in the chat box. Please show some energy in the chat box. Then we are going to start this session with questions. Some of the questions are basics and fundamental questions, some of the questions are on tougher side, some of the questions are on moderate side. So we have to practice all type of questions. Okay, so we are going to discuss some beautiful questions. Okay, in starting there will be some basic questions, है ना, question discussion. Okay, digital logic, है ना, digital logic. And one of the most important thing I want to tell you that many of you, while solving questions, you try to answer as quickly as possible. Don't do that. Do at your own speed, because ultimately you have to solve a question correctly. Okay, so try to solve at your speed, whatever your speed is, because accuracy is more important compared to the speed. If accuracy along with speed is there, then that is the beautiful thing to do. But you are only running after the speed and there is no accuracy, then that is meaningless. So accuracy comes first, then you can, by practicing, increase your speed of solving questions. Okay, so firstly I want from all of you that you solve question accurately. Whether you take half minute extra or 1 minute extra, that doesn't affect your result. Okay, so this is the first question. Okay, this is the first question. You need to solve it. It belongs to number system. Please solve it quickly. Everybody will answer in the comment box, है ना? Accuracy is the most important thing. If you know 50 questions, if you are able to solve 47-48 questions accurately, you are going to get a very good rank in GATE examination. You know 55 questions, but in hurry, in trying to achieve speed, if you are solving in hurry, you will be solving many questions wrongly, or you will be ending up finding wrong answers, and then your score will not be good. Out of 55, if you will solve around 10 questions incorrectly, then your score is going to be poor compared to a student who knows only 50 questions but solved 47-48 questions accurately. Okay, so that is very, very important. Three numbers x, y, z are represented in 2's complement form such that x is 10 4 times 1, 110 4 times 1, 1110 4 times 1. So if you look at very, very closely, here x, here 1 is copied one more time here. If you look at closely, in case of y, same x is here and only MSB is copied one time to the left. Okay, here also this is x only, and here MSB 1 is copied two times into the left. And you know that copying MSB any number of times to the left of MSB will not affect the number in case of 2's complement representation. So all x, y and z are same. Firstly, all x, y, z are same. So here, where x, y, z all are not same will not be the answer, and only option A contains all x, y, z to be same. So I will not be solving this question in examination. Rather, I will directly pick the answer A. You don't need to solve it, okay? You don't need to solve it. If you want to find it, let us find out x, 1, 0. So this is property based question. So this MSB has a total negative weight 2 to the power 5 because there are 6 digits. It will start from 2 to the power 5 and in the last it will go up to 2 to the power 0. So minus 32 into 1 is minus 32. 16 into 0 is 0, plus 8 into 1 is 1, 4 into 1 is 4, plus 2 into 1 is 2, plus 1 into 1. So minus 32 plus 15 is minus 17. So the answer is minus 17, x, y, z all are minus 17. Okay. Okay. Let us move to the next question. Okay. Let us move to the next question. This question is also not a very tough question. And these kind of basic questions are repeatedly asked in your GATE examination. And in hurry, many students solve these questions also incorrectly. Please read the question carefully and then try to answer it. Okay. Yes, that will be sufficient for 𝐂𝐸 examination. Okay, beta. Don't, copy paste the same comment again and again. That is not a good behavior from a genuine student. Okay. So I have already answered your question, your query. So don't try to copy paste same comment again and again. Because this session is regarding question discussion. So don't try to affect, don't try to, okay, create some what I'll say, जाने दो, है ना, ठीक है, A answer, है ना. So for y to be 1, they want your y to be 1. They want your y to be what? They want your y to be 1. Generate y to be 1. So for y to be 1, what is this gate is AND, and AND gate produce only in one case output y1 when all the inputs will be 1 for surely. Because if any one of the input will be 0, then 0 into anything will become 0. Okay. So all inputs should be 1 in case of AND gate for output to be 1. Now this x3 is definitely 1. So in this x3 is 0. In all other options x3 is 1. Okay. Now for this XOR gate to be 1, 0 XOR 1 is only 1 because this should also be 1. So x2 should be 0. Here x2 is 1, so this is wrong. Here x2 is also 1, it is wrong. And for this XOR gate to also produce output 1, 1 XOR 0 will be 1, so this x1 should be 1. So x1 and x3 should be 1 and x2 should be 0. So the A is absolutely right option for this question. A should absolutely right option for this question. So x1 and x3 should be 1 and x2 should be 0 for generating all ones for this AND gate, and then output y will become 1. Okay. Now let us solve a very beautiful question belongs to number system. Let us solve a tricky question. We'll mix it up. Okay. Some easy and fundamental questions, some tricky questions. So this is a very beautifully framed question. The relation between two numbers represented in base x is given. 225 base x is 15 base x square. The minimum possible value of x is, they are asking about the minimum value of this base x. Minimum value is asked in this question. Okay, try to find out the answer for this question. Try to find out the answer for this question. Very beautifully framed question. Okay. So in case of AND gate, you have to start with from the output side. For output to be 1, all the inputs of AND gate should be 1. And for all inputs should be 1, x3 is directly to the AND gate, then x3 should be 1. And accordingly, for XOR gate to generate output 1, both inputs should be different. So if one of the input is 1, the other one will be 0. If one of the input is 0, other will be 1. That's how you need to solve the question. The relation between two numbers represented in base x is given below. Firstly, number should be correct, then only the relation should be correct. So for numbers to be correct, x should be greater than or equal to 6. Isn't it or not? X should be greater than or equal to 6. Why, sir? Because the highest digit here in both the sides, because both the numbers are in base x, on both the sides, the highest digit appeared in the number is 5. So for 5 to be a valid digit, then only this number, both side number will be valid. So for 5 to be a valid digit, base should be at least 6, because base is 6, the highest digit you can use is 5. And if base is higher than 6, then definitely 5 will be a valid digit. So x should be either greater than or equal to 6. First condition is this. Now this relation should also be true. Let us convert both the numbers in what? Base 10, and then try to equate these relations and try to find out the values of x. Only those values of x will be accepted which are greater than or equal to 6. Okay, let us try to find out the solution. Don't directly put the answer to be 6, because this condition is only for this to be correct number, this to be correct number. We haven't solved the relation yet. Now we are going to solve the relation. Now this is x square, this is x to the power 1, this is x to the power 0. This is x to the power 1, x to the power 0. Now convert this into base 10. 2 into x square plus 2 into x plus 5 into x to the power 0. This is in base 10 is equal to x to the power 1 into 1, x 5 into x to the power 0 square in base 10. Now let us solve for x. The only values of x accepted here will be which are greater than or equal to 6. Now this is 2x square. Now we will find out x in base 10, obviously, because this equation becomes is now in base 10. So this is x square. This is 25 plus 2 into 5 into x is 10x. Now x square cancel out, x square plus 2x minus 10x is minus 8x, minus 20 is equal to 0. So this is 20 and 8. 10 into 2 is, yes. So x minus 10, x plus 2 is going to be 0. So this is x square minus 10x plus 20 minus 20. Okay. Now x is 10 and x is minus 2. So for these 225 base x to be equal to 15 base x should either be 10 or minus 2. So for these to be equal, this relation to be true, either x should be 10 or minus 2. But x cannot be less than 6. It should be either equal to 6 or greater than 6. Then only these numbers will be corrected. So for this relation to be true, x should be 10 minus 2, and for numbers to be true, x should be 6 or any number greater than 6. So overall, numbers to be true and this relation to be true, only x is equal to 10 value is accepted, because for x is equal to 10, this relation is also true, and for x is equal to 10, both numbers are correct. Okay, so x is equal to 10 is only the solution of this equation. So this is the minimum value also, this is the maximum value also. Every minimum, maximum, average, all the values are 10. So the answer is 10. Okay. Many students, what they fill the answer to be 6, because they know that x is greater than or equal to 6. So 6 is the minimum value, sir. But for 6, whether this relation will be satisfied? No, sir. This relation will not be satisfied. So x is equal to 10 is the only answer for this equation to be true. And for this equation to be true, number should also be true. Okay. Both conditions should be satisfied. So 10 is the right answer. Okay. Many students find out the answer correctly. Okay. Now solve this question. Now solve this question. Very good. Very, very good. Okay. No, beta. Base will always be integer and positive, है ना? and it should always be greater than or equal to 2. It cannot be 1. If you will take base to be 1, the digit you can use is only 0, and with only one digit 0, you can only able to write out the number 0 only, no other numbers. So base 1 will also not be a, you can say that, a practically feasible base. You cannot able to write out any number other than 0 if base is 1, because if base is 1, maximum digit you can use is r minus 1, that is 0 only. Okay, so base is always positive and it is an integer number. Digits are also integer. Okay, let 1010 XOR x is 1100. So the XOR operation, the value of x in decimal, they have asked you the value of, so x, let's say x is A3, A2, A1, A0. We have to XOR corresponding bits. So 1 XOR A3 is going to be 1. You want 1 XOR A3 to be 1. So for that A3 will be 0. Okay. Now what A2 will be? 0 XOR A2 you want to be 1. 0 XOR 1 will be 1 only. So A2 will be 1. A1, 1 XOR A1 should be 0. 1 XOR 1 will only be 0. So A1 will be 1. Okay. Now A0, 0 XOR A0 should be 0. 0 XOR 0 only 0. So this is 0, 1, 1, 0. So your x is nothing but 0, 1, 1, 0 base 2, which is 6 in base 10. So the answer is C option. 6 is the right option. Answer is C, that is 6. 6 is absolutely right option. Absolutely right option. Okay. Now let us try to solve a very beautifully framed question, this one. Minimum number of NAND gate. Minimum number of NAND gate. We can apply exchange property also. Exchange property is in case of that that should be a single variable. Okay, that should be a single variable. You cannot say that if x should be here and 110 should be here. Okay, that is not. Here corresponding digits are XORed. Okay, so you cannot apply exchange property over here. Exchange property is applied when a is a single variable, that is a single digit. Corresponding to single digit you can apply exchange property. Okay. So you have to solve every bit, for every bit. Okay. Exchange property is A is a single variable, B is a single variable. If A XOR B is C, then A XOR C will be B. Okay. That should not be A should be a 4-bit, B should be a 4-bit. No, A and B should be single bit. Then only that is valid. Okay. Then only that is valid. F of ABC is AB plus A bar C plus B bar C. Minimum number of 2-input NAND gate required to implement above function is. Okay. Okay, Ashika? Okay. Try to solve this question. Four, 5, 6, 3. If you can simplify the function, try to simplify the function. If you can simplify the function, try to simplify the function. Because in order to find out the minimum number of NAND gate, your function should be as simplified as possible. And there are two methods of simplification. Okay, 4, 5, 3. So this is a good question. I can say that because there are different answers in the comment box. Now let us try to, you can say that, can redundancy theorem be applied here? Can we apply redundancy theorem? For redundancy theorem, there should be a variable which should be in both the forms. So here it is A, here it is A bar. So let us try whether redundancy theorem is applied or not. So A and A bar, apart from A and A bar, there is B and C. If B and C comes over here, that will be redundant term. But B bar C is here, so this is not applied. Redundancy theorem can be applied with respect to B and B bar also, because they are also here B bar. Apart from B, there is A. Apart from B bar, there is C. If A into C will be here, then that will become redundant. But that is not the case. So, redundancy theorem is not applicable. Now, any other theorem you can apply? Always, if you are not able to think the theorem, then solve it using K-map, bachcha lo. Solve it using K-map. Because many of you sometimes will not able to think about the theorems which are not directly applicable. Here theorem is applicable, but that theorem is in hidden form. So you can solve it by K-map also. Simplification can always be done using K-map. Okay. So if you are not able to apply theorem, let us try whether this can further be simplified or not by using K-map, because K-map will tell you whether this function can be further simplified or not. And I have already taught you in the paid batches, also in the digital electronics playlist where there are 14 lectures on Gate Wallah EEC channel, how to fill the function directly into the K-map without converting it into canonical SOP form. This AB is a pair. Why, sir, this AB is a pair? Because there are this is a three variable function, and one variable is missing. One variable is reduced when pair is formed. Two variables are reduced when quad is formed. Three variables are reduced when octet is formed. So C is missing. Okay. Now we have to retain A and we have to retain B. If pair will be formed over here, here, or here, here, or here, here, A will be retained, and to retain B, you have to fill two ones here. If I'll form this pair, A from here, B from here will be retained, and I'll get AB. How to retain A bar C? It is also a pair because one variable is missing. A bar from here and C from here to here. So here also a pair is formed. B bar C, here, this is a pair. Yeah, this pair is B bar C. Now I can solve it very easily. This is a quad, very easily, and this is a pair, my dear friends. Okay, this is a pair. Now the simplified form of it is C, B is removed, B bar B, A bar A removed, only C will be retained over here, and from here AB, C plus AB. So now this function is simplified to AB plus C. Now there is no hidden NAND at all. There is no hidden NAND at all. There is no hidden NAND at all. Okay. Now directly can take F bar, AB plus C whole bar, which will be AB bar into C bar. For this to be generated, I'll take one NAND gate where I'll put A and B, I'll get A into B whole bar. I'll take another NAND gate and I'll apply both input to be C and I'll get C bar, and I'll take C bar to be Q. One NAND gate, because to generate C bar from C we require one NAND gate. Now only I have generated P and Q, and this is P into Q, because P has generated, this is P and this is Q. So F bar is P into Q, so F is P into Q whole bar. I have got P using one NAND gate, I have got Q using one NAND gate, but in order to have F, we need to generate P into Q whole bar, and for that I require one NAND gate. I'll apply P and Q to the NAND gate, I'll get P into Q whole bar. So total 3 NAND gates will be required. Total 3 NAND gates will be required. And from here, how that simplification can be done? If you look it closely, here only I can take C common. Nothing else is possible. So if you want to apply theorem, then take common wherever is possible, because nothing is working over here. Redundancy theorem is not applied. So here only C can take and be common. And as soon as I'll take C common, A bar plus B bar. And if you look it closely, AB plus C, A bar plus B bar can be written as A into B whole bar. And now if I'll assume AB to be some Z, then Z into C Z bar. Now I have already told you a same variable is in both format, then distribution of R over AND is very useful. Now I'll distribute this Z plus over C and Z bar. Z plus C, this into is remained Z plus Z bar, and Z plus Z bar is going to be 1. You will remain with Z plus C, and Z is AB. So AB plus C is your final answer. Many times theorem students don't able to find out the theorem directly, okay, then go with the K-map. You have to solve the question correctly. When theorem, you find out theorem application of theorem is little bit tougher, then always go with K-map. If simplification at all is possible, you will find out the simplification. If simplification is not at all possible, then again after filling the K-map, you will get 3 pairs and you will get the same expression. So at least you need to check it, because you are not able to apply theorem. So then you might think that this cannot be simplified and you end up finding out the wrong answer. Okay, then always go with the K-map. If simplification at all is possible, that will be done using K-map. If that is not possible, K-map will also not simplify this function further. Got my point or not? इंग्लिश चैनल पर सर को इंग्लिश में बोलना पड़ेगा है ना, ठीक है. हाँ, K-map is always, है ना. Now you got the point. You got the point. है ना. You got the point. You got the point. Now everything is clear. So you always have to find out the best route to find out the answer. Okay. So that's why I have taken this question, because many students will think that this cannot be simplified further. Go with the K-map. K-map will always give you the solution if minimization is further possible. Okay. Now everything is clear. Please tell me, CRC wala clear, sir? CRC wala. Now I'll be taking a question related to counter. ओके बढ़िया, मजे आ रहे हैं. शाम वाले सेशन में आपके क्वेश्चंस और तगड़े लेवल के जो इस बार मैंने बनाए हैं ना, कुछ बड़े ही बेहतरीन क्वेश्चन उसमें है ना, ठीक है. सो बेसिकली वी आर रिवाइजिंग आवर सब्जेक्ट थ्रू दीज क्वेश्चंस. ओके, सो ट्राई टू एनालाइज योर कॉन्सेप्ट्स व्हाइल सॉल्विंग द क्वेश्चन. ओके, so many of you are solving very correctly, and that is a very good and very positive sign for GATE examination. Okay, now try to solve this question. Try to solve this question. Okay. Okay, solve this question. The initial state of mod 16 down counter. Mod 16 counter counts from 0 to 15 either in up mode or down mode. In down mode it will be decremented by 1 at every trigger, while in case of up counter mode it will be incremented by 1 at every trigger. Okay. Now it is counting from 0 to 15. 16 will not be a state in case of mod 16 counter. If I'll say that there is a mod 128 counter, the states will be from 0 to 127. Total 128 states will be there, but 128 will not be the highest state. Please remember always, because this mistake always happens by the students. Okay. Now the starting state of this down counter, it is a down counter. In rush you might take this to be up counter by default. Okay, so always read the question very carefully. So the starting state is 6, you can say that 6. Now mod number is 16, and I have already told you, after mod number of clock pulses or integer multiple of mod number of clock pulses, you will always add the starting state of the counter where you started from. Okay, now you started from 6. Now after how many integer multiples of 16 will be there in 68? 4 integer multiple of 16 will be there in 68, that is 64. So after 64 clock pulses, you will be at the starting state of the counter where you started from. Now, there are 4 clocks remaining. So in every clock, there will be decrement by 1. So in 4 clock pulses, it will be decremented by 4. So you will get your state to be 0, 0, 1, 0, that is 2. 6 minus 4 is 2. So the answer is 2. If I'll ask you, after let's say 74 clock pulses, what will be the state? Let's say 74 is asked. Now after 64, 10 clock pulses are remaining. So out of those 10 clocks remaining, in 6 clock pulses, it will be decremented by 6 and it will reach to 0. Now 4 clocks are remaining. Now in the next clock, 1 clock, from 0, it will count in reverse direction, 0 to 15. So it will go to 15. Now 3 clock pulses are remaining. Now in next 3 clock pulses, it will be decremented by 1 in every clock. In 3 clock pulses, it will be decremented by 3. So the answer will be 12. This can also be asked. This can also be asked. Okay. This can also be asked. Okay. Like this. So if you are decrementing your counter, so after decrementing, first reach to 0, then 0 to highest, and then again decrement it. Okay. That's how you can find out answer. This is the, if we instead of 68, 74 clock pulses are asked. Okay. So for this question, answer is 2. For this question, answer is 2. Very good. Many of you already find out the answer. Now this is a very beautiful question. This is again a very good question. It might be asked, but chances are less, but it might be asked. Decoder is normally not asked in this kind of questions. Normally mux is asked, but to realize the concept, I have taken this question. Okay. A designer has sufficient number of units of decoder with enable input of size 4 into 2 to the power 4. This statement is very, very important, whatever is written over here. And a decoder of size 8 into 2 to the power 8, because decoder is always n is to 2 to the power n. Okay. So this is 4 is to 16, this is 8 is to 256. Is to be realized, the number of units of 4 is to 2 to the power 4 decoders required will be. What is the answer? This is a very, very beautiful question. What should be the answer? Please tell me. What should be the answer? 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 32, some of you are saying 32, some of you are saying 2, some of you are saying 16. Now, I'm giving you 2 to 3 minutes. Let us solve it. Some of you are finding out 2, some of you are finding out 17, some of you are finding out 32. No. Okay. We'll try to find out. I'm giving you some time. Think about it and then solve it. Okay. Think about it and then solve it. Okay. Think about it and then solve it. Okay. 3, some of you are saying 3. I think 3 is not the right answer. 3 is not the right answer. 3 is not the right answer. Some of you are not able to correlate it. Okay. Some of you are not able to correlate it. Try to correlate it and you will find out the answer. Some are finding out the answer from the input side. Some are finding out the answer from the output side. And some of you are thinking, what is going on? What is going on in this question? We know how to find out the number of mux required, number of demux required, but we don't know how to find out the number of smaller decoders required in order to design a higher order decoder. Okay, now let us try to solve it. Always try to correlate. Okay, decoder with enable input is equivalent to what? Demux. Decoder with enable input is always equivalent to demux. So basically, whenever you are asked to find out the number of lower order decoder required in order to design a higher order decoder, always try to calculate as we do in case of demux. How to find out number of lower order demux required in order to design a higher order demux? From output side we always calculate. In case of mux we calculate from input side. In case of demux we calculate from outsides. And as this demux, this decoder with enable input is equivalent to demux, we here also will calculate from the output side. So in case of higher order decoder there are 2 to the power 8 output sides. Okay, so we will divide this 2 to the power 8, that is 256, from the lower number of output, lower number of output pins, till we get 1. So 256 divided by 16, then again 16 divided by 16 is 1. So this is 16 plus 1, 17. 4 into 2 to the power 4 decoders will be required in order to design one 8:2 to the power 8 decoder. Got my point? So in case of decoder, always do the calculation from output numbers, output pins. How many output pins are there in higher order decoder and in case of lower order decoder, because this is equivalent to a demux. So calculation will always be using demux. Okay, methodology. So the answer is 17. Many of you have done this 8 divided by 4 and then 2 divided by 4 is not possible. So one more. So 2 plus 1 is 3. Okay. Got my point? Every one of you got my point? CRC wala clear? CRC wala clear? Got the point? Why we have done this calculation? Why we have done this calculation? Bachcha lo. Why we have done this calculation? Why we have done this calculation? Now, one more easy question. Then we have some very beautifully framed question, okay, related to delay concept, in case of we can say that full adder, then related to mux, one very beautifully framed question is there. Then related to mod number, one very beautifully framed question is there. Got the point? Okay. Now solve this question. This is not a very tough question. Try to solve it. Try to solve it. Please read the question very, very carefully first in order to solve it. For the logic circuit shown if X, Y and Z are A6C hexadecimal representation given over the same time of interval, what will be the output F represent in hexadecimal? So this is a calculation based question. Okay. You can use your common sense also to solve it quickly. Okay, to solve it quickly. You can use your common sense also. How effectively you are solving the question, that matters a lot. Okay. So firstly, try to think over the question. Okay, what I can do? What are the circuits given to you? What is the circuit given to you? what is the functionality of this circuit, how XOR gate behaves, how AND gate behaves, how AND gate generates output. If you are able to correlate, you will be able to find out the answer quickly as well as correctly. Now let us see over here. This is X XOR Y. This output is X XOR Y. This output is Y XOR Z. And this is Z. Okay, no problem. X is what? X is A. A is 10. That is 1 0 1 0. Y is what? 6. That is 0 1 1 0. Because I will represent in hexadecimal. They have represented. So they are represented using 4 bits. Okay. C and Z is C. C is 12. A is 10. B is 11. C is 12. 1 1 0 0. Now you can say that. Now, this 1 0 1 are applied at the same time because same interval. Then 0 1 1 is applied X Y Z. Then 1 1 0 is applied. Then 0 0 0. Now tell me, this last 2 bit of Z is 0 and Z is directly applied to this AND gate. So I can directly say that last 2 bit of this F will definitely be 0. Last 2 bit of this Z will definitely be 0. For sure, for sure, for sure. Because if Z is 0, irrespective of other 2 inputs, F has to be 0. So last 2 bit will definitely be 0. So 7 cannot be the answer. The people who are giving the answer 7 cannot be possible at all. Because you have to, in this order, you have to apply input, and in this order, you have to generate output from left to right. As simple as that. Now I need to find out for these 2 inputs only. So first, let us, I am moving from right to left. So I will be finding out for this 0 1 1. So 0 XOR 1, this is 1. 1 XOR 1, this is 0. So and this Z is 1. So 1 0 1, this is again 0. So this is 0. Now for the first bit, 1 XOR 0 is 1. 0 XOR 1 is 1 over here. Okay. And now this is 1 again. So 1 1 1 is 1. So this is going to be this 1 0 0 0, which is nothing but 8. This is nothing but 8. Hexadecimal. 8. 8 in hexadecimal. This comes in binary. And if you group this 4 bits in hexadecimal, this will be 8. Okay. समझ गए question? What is the question? Got the point? Many times it happens. Students don't get the question. Okay. What it is saying. When we explain the question, they easily solve it. So always improve your try to improve your reading habit in this last 1 month. Try to understand the languages of questions. While solving PYQs, while solving test series. If some information is given in language form, what its meaning, how these informations are provided, try to learn those things. Try to analyze those things. Then only in examination you will be able to get the question rightly in one attempt, and then you will definitely be able to solve the question if you have the knowledge, you have the concept. Because many times when we don't get the question in the right manner or in the right sense, then even we know the concept very well, we don't able to solve it. Okay. Got the point? Got the point? Okay. Now let us move to the next question related to delay. Related to delay. Related to delay. I'll clarify this question firstly because we have framed this question. So what is the meaning of this question? Okay. Here each 1 bit full adder is designed using XOR and an OR gate. How this is designed? Using 2 XOR gate. Okay. Using 2 XOR gate, 2 AND gates and 1 OR gate. That is nothing but using 2 half adder and 1 OR gate. So here the meaning of each 1 bit full adder is designed using XOR and an OR gate. That is using 2 XOR gates, 2 AND gates and 1 OR gate. 1 XOR 1 AND gate, 1 half adder, 1 XOR 1 AND gate, 1 half adder and 1 OR gate. 2 half adder and 1 OR gate is equivalent to 1 full adder. So that each 1 bit full adder is designed using that only. Okay. Now solve this question. Very beautifully framed question. Okay. Now solve this question. In gate, they will clarify whether this full adder is, how it is designed using XOR and an OR gate. Okay, they will clarify for sure. Okay. Now this question, you require everything you know about full adder. A 16-bit parallel adder is designed using 16 1-bit full adders. There are 16 full adders are used for every bit position. Okay. Each 1-bit full adder is designed using XOR and OR gates. The delay contributed by XOR gate is 20 nanosecond, while that contributed by AND/OR gate is 5 nanosecond. The number of additions per second that a 16-bit parallel adder can perform reliably will be. बहुत ही बढ़िया question. Very, very beautiful question. Now this is a 2 marks question for sure. You require your every information, every analysis we have done in case of parallel adder and full adder, that is required over here in order to solve this question. So 2, 4, 2, somebody got the 2, somebody got 2.5, somebody got 4, fill in the blank. Okay. Everybody please solve it. I'm giving you around 2 to 3 minutes, and then I'll be explaining how to approach this question. How you should be thinking when you get question like this. Mahabhyas will be at 7 p.m. Everybody, every one of you, please present that session. Please be present in that session. The number of additions per second that a 16-bit parallel adder can perform. Now, if I will be able to calculate the worst case delay in performing one complete addition of two 16-bit numbers, then I can definitely calculate how many additions you can perform in 1 second. I need to calculate capital TD, the time taken by this 16-bit parallel adder to perform one complete addition of two 16-bit numbers. First thing I need to calculate is this only. Okay. Now here, for calculation of that worst case delay, now step by step calculation we can perform over here. Okay. Worst case delay capital TD, is nothing but, if there is a n-bit parallel adder, is nothing but n minus 1 TC plus max of TC TS. We know that, we know this thing, where TC and TS are carry and some delay of each full adder. So in order to calculate TD, I need to know this TC and TS. But here full adder is designed using 2 XOR 2 and 1 OR gate. So I need to design that circuit of full adder, and then I need to calculate this TC and TS from that circuit, because we know the delays of XOR gates and OR gates. So how we design full adder using 2 XOR 2 AND gates? xy, this is x XOR y. Now this is z, this is x XOR y XOR z. That's how we get the sum output. Okay. Now, how we calculate carry output? We take one AND gate, which is generating x into y. Now, this x XOR y and this z, we apply to another AND gate. We get x XOR y into z over here. Now, we take one OR gate, and by combining these two, x into y plus x XOR y into z, we get the carry output. Now, let us calculate the carry delay TC and let us calculate the sum delay S. This XOR gate has a delay of 20 nanosecond. These AND gates and OR gates has a delay of 5 nanosecond. Okay. So now, when you apply x, y, z at t is equal to 0, these two inputs are available at t is equal to 0. You get x XOR y at t is equal to 20 nanosecond. Now, for this XOR gate, one input z is available at t is equal to 0. But the other input is available at t is equal to 20 nanosecond. So when both inputs are available at t is equal to 20 nanosecond only, and when input is available after 20 nanosecond, it will generate the correct output. So 20 plus 20, it will generate some output after 40 nanosecond. So sum delay TS is 40 nanosecond only. Okay. Now let us calculate the carry delay. Now this xy is available at t is equal to 0, so you will get x into y at 5 nanosecond. This x XOR y is available at t is equal to 20 nanosecond, while this z is available at t is equal to 0 for this AND gate. So both inputs are available at t is equal to 20 nanosecond only. Z is available before x XOR y, but both will be available at t is equal to 20 nanosecond only, and after 5 nanosecond it will generate output x XOR y into z, that is at 25 nanosecond. Now for this OR gate, one input is available at 25 nanosecond while other input is available at 5 nanosecond. So when both will be available at t is equal to 25 nanosecond for sure. So when both inputs will be available at t is equal to 25 nanosecond, after 5 nanosecond it will generate carry output, that is at 30 nanosecond. So TC will be here 30 nanosecond. Now let us calculate TD is time taken by this full adder to perform one addition up to 16-bit numbers. Okay. Complete addition. Okay. So now this is 15 TC plus max of TC TS. Which is maximum? TS is maximum. So this is 15 TC plus TS. 15 into 3 is 450 plus TS is 40. This is nothing but 490 nanosecond. So to perform one complete addition, you require 490 nanosecond of the time. Now, in 1 nanosecond, how many addition you can perform? 1 upon TD. 1 second divided by TD. TD is time for one addition. So, in 1 second, how many addition you can perform? This is 1 second divided by 490 nanosecond. Now, nanosecond is in second. 10 to the power minus 9. Second got cancelled. 10 to the power 9 will be in numerator side. Now, 10 to the power 6 will separate. 1000 divided by 490 is your answer. So this will be 100 divided by 49. That is approximately 2 point something. So this is going to be 100 divided by 49. 2.04. So approximately 2. 2.04 is the right answer. Got the point? Here यानी 16 बेटा, यहाँ चिल्ला के यहाँ बता रहा है यानी 16 बेटा. तुम कहाँ से मीनिंग निकाल लो? इट इज 16. यहाँ लिखा हुआ है भाई. क्वेश्चन ध्यान से पढ़ना इसीलिए बहुत जरूरी होता है ना मोहम्मद भैया. Here यानी 16. Why here यानी 16? Because 16-bit parallel adder is here. Okay. So इसमें कोई रॉकेट साइंस नहीं था कि here why this is 16 है ना. ये रॉकेट साइंस नहीं था, हमने बहुत अच्छे से निकाला है. ठीक है, ये बहुत सिंपल सी चीज थी. चलो नेक्स्ट क्वेश्चन करें. नेक्स्ट क्वेश्चन, चलो तुमको थोड़ा इजी क्वेश्चन दे देते हैं. चलो इस क्वेश्चन को करो. Okay. But then the carry delay will be different. I have already told you how this full adder is designed. If this question will be asked in gate examination, they will mention you how this full adder is designed using XOR gate, AND gate and OR gate. Don't worry, why you are so much worried? Why you have so much worry, beta? If that is designed using 3 AND gate and 1 OR gate, then delay will only be 10 nanosecond. Because 5 nanosecond for first stage AND gate, 3 AND gate, and second stage OR gate will have 5 nanosecond of delay. So overall delay, carry delay will be only 10 nanosecond. So accordingly answer will be calculated. I have already told you in the starting of the question that this full adder is designed using 2 XOR, 2 AND and 1 OR gate. And that can only be possible using 2 half adder and 1 OR gate. That's how we have calculated like that. Okay. That will always be mentioned in the question. Okay. सीएम मौर्य जी, ठीक है ना? तो घबराया मत करिए भाई, डिले कैलकुलेट, इसको बबल मत ले लेना बेटा, ये कई बारी बस पिन को दिखाने का तरीका है, कई लोग कंफ्यूज हो जा रहे हैं भाई, है ना? ये हमारे टाइपिस्ट लोग कर देते हैं, बेचारे बच्चे कंफ्यूज, है ना? तो ये बस बबल नहीं है बेटा, है ना? है ना? इसको हटा दो, बबल मत ले लेना, है ना? बबल लेके कर रहे हो पता चले। हाँ 20 से ऊपर नीचे भी हो सकते हैं बेटा विजय, ऐसा नहीं कि 20 क्वेश्चन होंगे, ये क्वेश्चन इररिलेवेंट है ना, 20 क्वेश्चन होंगे, 25 होंगे, 18 होंगे, है ना, डजंट मैटर। इफ यू आर इन द सेशन, एंजॉय द सेशन, है ना, सॉल्व द क्वेश्चंस which we are discussing over here, है ना। Consider the configuration of 2:1 mux as shown below. It is required to implement two variable Boolean function f is equal to p plus q. Now in two options select line is p, and in one of the option z is 0, select line z is 0, and one option z is q. So firstly let us take z to be p. Now directly how to implement function I have already told you, है ना। If p is 0, this mux will only transfer d naught at the output. So at p is equal to 0, what will be the output of this function? 0 plus q. Function will transfer at the output q at p is equal to 0, and mux is transferring d naught at the output when p is equal to 0. So if I'll make d naught to be q, then function functionality and mux functionality will match. So d naught should be q, and what should be? D naught is x, so x is q basically. And when p is 1, mux will transfer d1 or y at the output. What function will transfer when p is 1? 1 plus q is 1. So function is transferring 1 at the output while mux is transferring y. So if I'll make y to be 1, then mux will also transfer 1 at the output when p is 1. Now the function functionality and mux functionality got matched. So if z is p, x should be q and y should be 1. This A answer is absolutely correct. And this is an MCQ question, so I will not solve further. I will not solve further. If this is an MS2 question, then this P, for P, this option is correct, this option is wrong. Now I will inquire this option C and D also if this is a MS2 question. Because if I'll put Q to be Q at here, then also this function can be implemented. Then P will be here at the input side, X and Y. Okay. But this is an MCQ question, so if one of the option is correct, then I don't need to bother about other options. Okay. So I'm not solving further. Okay. So this A option is correct. If this is a MS2 question, then when select line is Q also, you need to check whether D option is correct or not. Okay. So always be careful. Now one of the very beautifully framed question. Let us take this question. Okay. This is a very, very good question. Solve this question. This is again a very good question related to mux. There are 1 2 is to 1 mux, 1 4 is to 1 mux, and then another 2 is to 1 mux. this is not over here. Okay, solve this question. That is typing mistake. Number of combinations of x, y, z for which f will be 1. That will be given in question, beta. That will be given. This is MCQ question, hai na? That will be written. Okay, that is not a problem. Don't worry about this. That will always be mentioned. This is MSQ question or MCQ question. So number of combinations of x, y, z for which f will be 1. How many different combinations are possible from x, y, z? There are 8 different combinations are possible from 3 variables x, y, z. So out of these 8 combinations, in how many combinations this f you are going to get as 1? That is what you are asked to find out over here. Any of you? Any of you? In this kind of question, what you need to do is just find out this function f. This function f will definitely be function of 3 variables x, y, z, because x, y, z are applied on the input side of this, mux. So f will definitely be function of 3 variables x, y, z. And if you will be able to find out the SOP expression of x, f in SO, because there are 8 terms from x, y, z, you can apply 8 combination, or those 8 combinations are 8 terms for the function, and f will be 1 for those terms which are there in SOP. So if I'll be able to find out the SOP canonical expression of f, so firstly find out f, minimize the expression of f in terms of x, y, z, and from that find out the canonical SOP expression of f. If there are 5 terms in SOP expression of f, means for 5 combination, because those 5 terms are 5 different combinations out of total 8 combination. For 5 combination f is 1, for remaining 3 combination it is 0, that will be in POS expression. So whenever you are asked to find out in how many combination f will be 1 or f will be 0, just find out the expression of f. Getting my point or not, bachcha log? Getting my point or not? Because in SOP expression, how many terms are there? For those number of combination, your f is going to be 1, and the terms which are there in POS expression, for those number of terms, your output f is going to be 0. This point is clear? Please tell me. Is this point clear or not? Is this point clear or not? Please tell me, everyone. Now let us solve it. Always remember, if all the input lines of a mux are same, then irrespective of the select line, output is going to be that input line, because when y will be 0, then only it will pass I0, and that is x. If y is 1, then also it will pass I1, that is also x. So output will always be x. Either you can expand it. Okay. So when all the input lines of a 2:1 mux or 4:1 mux or 8:1 mux are same, then output will be that input only, irrespective of the select line. That is a very beautiful concept. So this output will directly be x. Always try to find out the function f in terms of x, y, z. Okay. Getting my point or not? This is f. Either you can expand it. Let us expand it. When S0 is 0, that is y bar into I0. I0 is x. When S0 is 1, that is y into I1 is x. If you take x to be common, y bar plus y is 1. That is x. Always. Okay. Now here this S1 bar is permanently fixed at 1. Now how to write down this output? Let us take this output to be y1. So let us write down the output y1. Now z can be 0, z can be 1. When z is 0, that is z bar, because you can vary only z over here. So when z is 0, this is very tricky. You are not selecting all the input lines of this 4:1 mux. Why, sir? Because only one variable is there in the select line. So that can take only 2 values, and that's how you can select only 2 inputs out of 4 inputs over here. So when z is 0, that is z bar, the input goes to this mux is 1 0, that is input 2, and for input 2 it will select this I2. I2 is xy bar plus when z is 1 is or z is 1 into, when z is 1, this is 1 1, that is I3 into 3, I3 is 1. So you will be getting z plus z bar xy bar. Now you can simplify it by using distribution theorem, because z is over here and z bar over here. So z plus z bar is going to be 1. I am taking it to be z bar into xy bar. So z plus z bar into z plus xy bar. Okay, so z plus z bar is 1 into z plus xy bar. So this is z plus xy bar. This is y1. So I am taking it to be y1, and I am taking here y1 bar, because this y1 comes over here, and so I'll be solving this f in terms of y1, and in the last step I'll put the value of y1 to be z plus xy bar. Okay, now this is y1 bar. This y1 is also applied over here at I0 y1, and this x is coming over here at this point. Now let us expand it. Always expand it in terms of select input. When S0 double dash is 0, that is S0 double dash bar into I0. Into I0 is nothing but y1. I0 is nothing but y1. Or when S0 double dash is 1 into I1. I1 is x. Now S0 double dash bar will be, S0 double dash is y1 bar. So S0 double dash bar will be y1 bar is y1. So y1 into y1 will be y1 plus S0 double dash is y1 bar into x. So y1, here also you can apply the distribution theorem, because y1 here y1 bar. y1 plus y1 bar into y1 plus x. y1 plus y1 bar is 1, and y1 plus x. You will get y1 plus x. Now put the value over here. y1 is z plus xy bar plus x. Now you can take x common from these two, y1 bar plus 1, y bar plus 1 is 1, so you will get z plus x as the final value of f. So you are getting f to be x plus z. This is a 3 variable function. Y is removed because of simplification. Now find out the canonical expression of x plus z. X, it represents 4 terms. Why? Because 2 variables are missing. X is fixed at 1. Y and z could take value 0 0, could take value 0 1, could take value 1 0, could take value 1 1. Okay, so this is term 4, this is 5, this is 6, this is 7. You can also ask to find out the function f, which is x plus z. Okay, now z is 1. X and y are missing. They can take 4 possible values 0 1. Position of x y is over here 1 0 and 1 1. So this is term 1, term 3, term 5, term 7. So overall the canonical SOP expression, term 1, term 3, term 4, 5 is over here also, 5 is over here also. We can write only one time, because 5 plus 5 is 5 only. Term 6 over here, and term 7 is over here, also over here. So 2 terms are common. Okay, term 5 is only common. Okay, 1 3 5 and 7. So only 5 is common. So 1 3 4 5 6 7. So term 5 is common only. 1, 3, 4. So total 8 terms are here. 1, 3, 4, 5, 6, 7. 1 is here, 3 is here, 4 is here, 5 is here, 6. 2 terms are common actually. Why? That's why I confused. 5 and 7 are common. So total 8 terms are here, but 2 terms are common. So overall 6 terms are there in SOP expression. So for 6 combination of X, Y, Z, है ना, combination 001, combination 011, combination 100, combination 101, combination 110, and combination 11, you will get output F to be 1. For remaining 2 combinations that are 2 and 0 and 2, you will be getting 0 at output F. You will be getting 0 at output F. Okay. So in this kind of question, always try to find out the final expression of F and find out its SOP canonical expression from its function. Okay, canonical SOP. How many terms are here? For these number of combination, output is going to be 1, and for remaining combination, output is going to be 0. This is the easiest way to solve this kind of question. Don't try to put the values X, Y, Z to be 0, 0, X, Y, Z to be 0, 0, 1. That is a very lengthy method. Always try to simplify this function and use the findings, use the rules easily, because if all the inputs of a mux is same, output is directly that input. Use this kind of simplification processes. Okay. Okay. Clear? Clear? Clear, bachcha log? Clear? Now let us solve this question. Okay. Now one question from counter. Firstly, a easy question and then a tricky question. Solve this question. Clear? 6 is the right answer. 6 is the right answer. Okay. So always try to find out the function. Then we will get the answer eventually. Okay. The frequency of the clock signal applied to the negative going edge triggered JK flip flop shown below is 15 kilohertz. What is the frequency of the signal available at Q? इस बबल, ये बबल नहीं है, जस्ट आउटपुट को शो करने का तरीका है ना. कई बार हमारे टाइपिस्ट लोग इस तरह से दिखाते हैं, आप परेशान मत हो जाइएगा, है ना. बबल के चक्करों में बबल ही कर रहे हैं आप, बबल बबल कर रहे हैं, बबल बबल खेल रहे हैं. The frequency of the clock signal applied to the negative going edge triggered JK flip flop shown below is 15 kilowatt. What is the frequency of signal available at Q? Beta, many students want mixed language. Okay, so every video cannot be done in English, beta. That is not possible. If you are in English batch, everything will be taught in English. Okay, we'll teach in English only. Okay, but in Hindi batches, Hindi plus English batches, explanation will be mostly in the mixed language, Hindi plus English. It cannot be completely in English. Students are also not comfortable, and we teachers also many times are more comfortable in mixed language. Okay, that is the reason. Okay, now always write down the characteristic equation. Always write down the characteristic equation, because this one flip flop based counter, or there are 2 flip flops, there are 3 flip flops, the state of the counter will be generated according to the characteristic equation. And if we know the states of the counter, we can find out the output frequency at any output. Okay, now Qn plus 1 is nothing but J Q bar n plus K bar Qn. Now put the value of J and K. This J is present input, and present input is always given by present output. Whatever is at the output is called as present output, and present output can only drive the present input. So J is connected to Q bar means J present input is driven by present output Q bar n. So Q bar n into Q bar n plus K is 1 bar into Q1. 1 bar is 0, 0 into Q1 is 0 and Q bar n into Q bar n is Q bar n. So this is operating in toggle mode of operation. So if you will start with 0 at first negative edge because it is negative edge triggered. So at every trigger, because this characteristic equation will be valid when flip-flop will get triggered. So this flip-flop when triggered will go to next state according to this characteristic equation, and where it will go? Complement of the present output state. So as soon as it will be triggered, present output state 0, it will go to 1. At next trigger, present output state is 1, it will go to 0, and then next state again 1. So it is 0, 1, 0, 1. There are two states, 0 and 1. It is mod 2 counter. And mod 2 counter will divide the frequency by 2 at the output, FCLK by 2. So if input clock frequency is 15 kilohertz, the output frequency will be 15 by 2, that is 7.5 kilohertz. 7.5 kilohertz. 7.5 kilohertz. Getting the answer? Now, let us discuss a question related to counter. There are two questions for one diagram. This is the first part of the question, and same question, in the same question, you are asked to find out the mod number. Please, this is the bubble now. This is the bubble. This is NAND gate, AND gate plus bubble, AND gate plus bubble, AND gate plus bubble. And this is not a bubble. This is not a bubble. This is only the output. Many students will get confused. This is not a bubble. Okay, this is not a bubble at all. Okay, let me correct it. Okay, this is not a bubble. This is only the representation of output Y. Others are bubble. They are NAND gates basically. Now solve this question, and it has a second part also. We'll be solving that question also. A circuit for truncated ripple counter. Truncated, you are breaking the counter. It is not a free running counter. If it is a free running counter, mod number will be 16, but its mod number will not be 16 because clear pin is used, and by using clear pin you have truncated this counter in between. So a circuit for truncated ripple counter together with a reset function labeled Y is shown below. The reset function Y can be expressed as this is Y, this is Y. You are asked to find out this Y. This Y. What is this Y? This output. This output is Y only. Okay. So this is Y, and Y is applied to this NAND gate, and this will generate Y bar, and which is passed on to clear pins. Okay. So you are asked to find out Y. This Y. What is this Y? This is a simple part of this question. The second part is you need to calculate the mod number for this counter. Okay. Now, what is this? This is a very easy calculation. This is a combinational circuit. We need to calculate it. Okay. So for this NAND gate, what is input? This is Q2 input. This input is Q3. So this is Q2, Q3 for this NAND gate. And for this NAND gate, Q3 is directly applied, and from here Q1 is applied. So this is Q3 and this is Q1. This is Q3 and this is Q1. Now, this output will be Q2 into Q3 bar. This output will be Q3 into Q1 bar. Now, how to write down the output Y? I have already told you, in case of NAND gate, there are two ways of writing down the output. Either multiply all the inputs as it is and then take a whole complement, or invert all the inputs and add them up, because NAND is a inverted R. NAND gate is a inverted OR gate. Okay. So if I'll invert this first input, it will become Q2 into Q3 because I'll take a bar over here. This bar will remove this bar. If I'll invert this input, it will become Q3 into Q1 because this bar will be removed. I'll take another bar and then add them up. So from here you will take Q3 common, Q2 plus Q1. So this is Y, Q3 into Q2 plus Q1. So the A option is absolutely correct option. A option is absolutely correct option. Please tell me. A option is absolutely correct option. Now in the second part of the question, same question, you are asked to find out the mod number of this counter. You are asked to find out the mod number of this counter. Only mod number. Firstly, you please find out whether it is up counter or down counter. Okay. This is low enable clear pin. This is low enable clear pin. Okay. Find out the mod number of this counter. Find out the mod number of this counter. In order to find out the mod number of the counter, you must be knowing whether your counter is up counter or down counter. And nothing is mentioned, so you have to take your clear pin to be asynchronous in nature by default. It is nothing to do with the type of counter. Okay, if nothing is mentioned, we always take, okay, clear pin to be asynchronous in nature. So at whatever combination clear pin will be activated, at whatever combination clear pin will be activated, that sequence or that state will not be counted in mod number. Okay. Now when this clear pin will be activated, when this NAND gate will generate output 0, and NAND gate generate output 0 only in one case, when both the inputs are 1, and for both the inputs are 1, Y should be 1, and Y we have already calculated Q3 into Q2 plus Q1, isn't it? So for Y to be 1, then if Y will be 1, then only both inputs to this NAND gate will be 1, and then only it will generate output 0, and then only clear pin will be activated. So let us find out at what combination clear pin will be activated first. Now for Y to be 1, this product should be 1, and for this Q3 should definitely be 1, and Q2 plus Q1 should be 1, and for Q2 plus Q1 should be 1, there are three possibilities. There are three possibilities. Q2 है ना, Q1 can take either value 0 1 or 1 0 or 1 1. All these possibilities are there. That means Q3, Q2, Q1, if I'll put together, what combinations, for what combination this can generate Y1, and then this NAND gate can generate 0. Q3 is fixed at 1. Q2, Q1 could be 0 1, 0 plus 1 is 1, and then 1 into 1, this is Y1. Q3 is 1 because OR gate can generate output 1 for if any one of the input is 1 or both of the 1, है ना, 1 0 or 1 1. All these three possibilities are there. Okay. Now here external clock is directly applied. This is LSB bit of this asynchronous counter, and this is MSB bit for sure. Now this is up counter. Why, sir? Here non bar, here bar, non bar bar, non bar bar. So every internal connection is up counter mode. So this is up counter for sure. Now any of these combination will appear at Q3, Q2, Q1 will activate clear pin. So which one is appear first will clear the clear pin, will activate the clear pin. Then other combination will not be possible. Okay. So let us count the counter Q3, Q2, Q1, Q0. It started from 0 0 0, and at every external clock trigger it will be incremented by 1. Why? Because it is up counter. Okay. So in case of asynchronous counter, if it is up counter, it will always be incremented by 1 at every trigger, है ना? And if it is a down counter, it will be decremented. So until the clear pin is activated, your counter will be going up by 1 at every trigger till you get Q3, Q2, Q1 to be 101 or 110 or 111. Q3, Q2, Q1. Okay. So now this is 001. Whether this is activated clear pin? No. Either 101, either 110 or 111 should be there. And at next trigger it will be 010. At next trigger it will be 011. At next trigger it will be this. At next trigger this will be 101. At next trigger 110. At next trigger this will be this. At next trigger 100. This should be 101. At next trigger this is 1001. At next trigger it will be 1010. As soon as it will go at 1010, your Q3, Q2, Q1 will become 101 and Y will become 1 and the output of NAND gate will become 0 and it will activate clear pin instantaneously. So as soon as you will get 1010, clear pin will be activated and that will clear the output to 000 because clear pin of all the flip-flops will be activated because this is connected to clear pin of all the flip-flops. So this state exists momentarily and will not be counted in mod number. You will get state from 0 to 9. Total 10 states are there. So it will be a mod 10 counter. Mod 10 counter. Mod 10 counter. Okay. This is a mod 10 counter. So the answer is 10. 11 is also here. But 11, this state will be counted only if the clear pin is of the nature of synchronous nature. And then mod number becomes 11 because this state will be counted then. Okay. Okay. Clear? Clear बच्चा लोग? जल्दी से बताइए. Clear बच्चा लोग? This is a MCQ question. Is the oblique R? This is a sign of MCQ question. Only one option can be correct or more than one option can be correct. Solve this question. Solve this question. At 7 p.m. there is another session of question discussion, Mahabhyas. And there I will be discussing some very beautifully framed new questions. Okay. Tougher than these questions. Hai na? Some of the questions are very beautiful questions. Okay. Which of the following statements is oblique R true? The number 0011101.1100 on base 2 is equivalent to 1D.3 on base 16. The number 0010001.100 on base 2 is equivalent to 11.4 on base 8. The number 112 on base 4 is equivalent to 211 on base 3. The number 214 on base 5 is equivalent to 3B on base 16. सॉल्व करिए जल्दी से. इस तरह के क्वेश्चन आते हैं सीएस में, तो बहुत फ्रिक्वेंट क्वेश्चंस हैं इस तरह के, रिसेंटली आए हैं. नंबर सिस्टम के लिए थोड़ा फेवरेट टॉपिक है. ABC बताइए भाई. चलिए इसको देख लेते हैं. अगर हमें बेस 16 में बनाना होता है तो इंटीजर पार्ट में आप राइट टू लेफ्ट ग्रुपिंग करते हो 4-4 का, क्योंकि लेफ्ट मोस्ट में 0 ऐड करने से इंटीजर पार्ट पे नंबर पे कोई फर्क नहीं पड़ता. और जो आपका डेसिमल पार्ट है उसमें लेफ्ट टू राइट करते हो, क्योंकि राइट मोस्ट में 0 ऐड करने में डेसिमल पार्ट में कोई, तो यहाँ 4 की ग्रुपिंग करते हैं ये. फिर यहाँ पे एक 0 ऐड करके 4 की ग्रुपिंग, तो 001 आ गया 1. ये 8 + 5 13 है. ये 13 को किससे लिखते हैं? 10 को A से, 11 को B से, 12 को C से और 13 को D से. 1 D पॉइंट, ये 1100, ये क्या है? 12 है. 12 है और 12 हो गया C, 1D पॉइंट C आएगा ये। सो 1D पॉइंट 3 इज नॉट द राइट आंसर। सो ये क्या हो गया भाई साहब, ये तो गलत है। ये लोग, कई लोग ए ऑप्शन कह रहे हैं भाई, 1D पॉइंट C है ना कि 1D पॉइंट 3 है। अगर ये 0011 होता तब होता। यहाँ लेफ्ट टू राइट ग्रुपिंग करते हैं बेटा, देखते तो यहाँ ग्रुपिंग राइट टू लेफ्ट करते हैं, लेकिन देखते तो हमेशा लेफ्ट टू राइट है चारों बिट को ना, चारों बिट को। तो ये 1D पॉइंट C है, तो ये तो गलत हो गया। ए ऑप्शन कई लोग कह रहे हैं भाई, कम से कम सही से लगाओ यार। द नंबर दिस ऑन बेस 2 इज 11.4 ऑन बेस 8। बेस 8 में कन्वर्ट करने के लिए 3-3 की ग्रुपिंग करते हैं। इंटीजर पार्ट में राइट टू लेफ्ट, क्योंकि लेफ्ट मोस्ट में 0 ऐड करने से कोई, और डेसिमल पार्ट में लेफ्ट टू राइट, है ना। तो यहाँ पे 3 की ग्रुपिंग कर लिया, 0 0 1 यहाँ, तो ये आ गया 1, ये आ गया 1 पॉइंट, ये 4 आ गया सीधे, 11.4 इन बेस 8। ये तो करेक्ट है भाई साहब, बी ऑप्शन इज करेक्ट। द नंबर 112 ऑन बेस 4 इज इक्विवेलेंट टू 211 ऑन बेस 3। तो कंपेयर कैसे करें, दोनों को डेसिमल में कन्वर्ट कर दो। जब अननोन बेसेस आते हैं तो उनको आपस में इंटर रिलेट करने के लिए हमारे पास एक ही माध्यम होता है, डेसिमल नंबर सिस्टम। कभी भी क्वेश्चन में कुछ भी ना समझ में आए, इफ यू आर नॉट गेटिंग एनीथिंग इन द क्वेश्चन, है ना, देखो मैं हिंदी में आ गया था, है ना, इफ यू आर नॉट गेटिंग द क्वेश्चन, है ना, तो आप डायरेक्टली कन्वर्ट दैट इनटू डेसिमल नंबर सिस्टम डायरेक्टली, ओके, then you will be able to correlate it, okay. So ये 4 to the power 0, and you can convert any base system into decimal number system just by expanding it, by multiplying with the corresponding weights. 4 to the power 2, 4 to the power 0, 4 to the power 1, 4 to the power 2, because base is 4. So 16 into 1 is 16 plus 4 into 1 is 4 plus 4 to the power 0 into 2 is 2, base 10. This is nothing but 22 in base 10. Now calculate this number, 211 in base 3, 3 to the power 0, 3 to the power 1, 3 to the power 2. So 9 into 2 is 18 plus 3 into 1 is 3 plus 3 to the power 0 into 1 is 1. So this is again 22 in base 10. So this is correct. So option C is also correct. 214 on base 5. 214, let's calculate this in decimal. 5 to the power 0, 5 to the power 1, 5 to the power 2. 25 into 2 is 50 plus 5 into 1 is 5 plus 5 to the, so this is nothing but 59 in base 10. Now calculate this 3b in base 16, it is 16 to the power 0, 16 to the power 1. Now 16 to the power 1 into 3 is 48 plus 16 to the power 0 into b, b is nothing but 11, 16 to the power 0 into 11 is 11. So 48 plus 11 is 59 in base 16. So base 10. So both are again equal. So option B, C, D are correct. Only A is incorrect. So option B, C, D all are correct. 3 options are correct. Okay. नहीं बेटा, पेयर हम जो 4-4 की ग्रुपिंग करते हैं, we are grouping in 4 bits. We are grouping 4 bits. In case of binary to hexadecimal conversion only. In case of binary to octal conversion only, we are grouping 3 bits, and there is reason behind it. We cannot discuss it, है ना? That will be discussed in detail in case of, है ना? When we will be taking detailed course, okay? So this grouping is only possible in case of binary to hexadecimal, grouping of 4 bits, and in case of binary to octal conversion, grouping of 3 bits. When you are converting binary into base 7, there is not a grouping method. You need to convert this into equivalent decimal number system and then decimal back to base 7. Okay. So this grouping is only possible in case of binary to hexadecimal and binary to octal. Again, this is a question. A ripple counter is required to count from. This is again a MSQ question. One option can be correct or more than one option can be correct. Solve this question. A ripple counter is required to count from 0 to 255 in decimal with input clock frequency of 512 kHz. Ripple counter means asynchronous counter. This is definitely a free running counter which is counting from 0 to 255. So this is a mod 256 counter. So you are required to design it using 8 flip-flops, because from 8 flip-flops we can have mod number 2 to the power 8, because we can use all the possible states from 8 bits, that is from 0 to 255. So the mod number of asynchronous free running counter designed using 8 flip-flop will definitely be 2 to the power 8, that is 256, which will be counting from 0 to 255. By default, it is counting in up counter manner if nothing is mentioned. Okay. The mod of the counter is 8. Whether this option is correct or wrong. Whether this option is correct or wrong. Mod of the counter is 8. Mod of the counter. Mod number is 256. This is wrong. Mod number is 256. It is counting from 0 to 255. The frequency of the output of the 8th flip-flop will be 2 kHz. So there are 8 flip-flops. You can say that it is from Q0 to Q7, Q7, Q6, Q5, Q4 है ना? Q3, Q2, Q1 and Q0. There are 8 flip-flops from Q0 to Q7. And in case of free running asynchronous counter, you know that at LSB position, this is the first flip-flop. LSB position flip-flop is called as first flip-flop. Frequency is divided by 2 to the power 1. At second, it will be divided by 2 to the power 2. So LSB is first, this is second. At second, 2 to the power 2. At third, 2 to the power 3. At fourth, 2 to the power 4. At fifth, 2 to the power 5. At sixth, in case of free running, it is possible. At seventh, 2 to the power 7. At eighth, FCLK by 2 to the power 8. So 2 to the power 8 is 256. So if the input clock frequency is 512 divided by 256 at Q7, that is Q7 is nothing but 8th flip-flop. Q0 is first flip-flop. So you'll be getting frequency at Q7, FQ7 is nothing but 2 kHz. So this is definitely a right answer. B option is correct option. So B is the correct option over here. The counter starts at all the bits, all 8 bits are 0, 0 means state 0. The state of the counter after 520 clock pulses, it is started with 0, and after mod number of clock pulses, it will again be at the starting state. So what are the integer multiple of 256 in 520? 256 into 2 is 512. So 2 into 256, after 512 clock pulses, it will be again at 0. And in next 8 clock pulses is remaining, it will incremented by 8, because at every trigger it will be incremented by 1, because it is by default a up counter. So 8. So how you write down 8 in 8 bits? 1000 is 8 and these 4 bits are 0. So this is again correct. The mod number of the counter is 256. Again correct. So here also B, C, D, all options are correct. 3 options are correct except option A. Except option A. Okay. Now, this is again a MCQ question. Very beautiful question. This is also a very beautiful question. Which of the following statements is oblique RR correct? This is again a MCQ question. Ankit Indian, beta C is also correct option. The logic gates NAND and NOR are commutative but not associative. Logic gates NAND and NOR are commutative but not associative. It is absolutely correct option. Why, sir? The universal gates NAND and NOR does not follow associative law, but they follow commutative law. All other gates R and XOR and XNOR follow both commutative as well as associative law. So this statement is correct. The logic gates AND, R and XOR are commutative and associative both. Absolutely correct. This is correct. All other gates follow both the laws, commutative as well as associative. It is not possible to use XOR gate as inverter. It is wrong option because XOR gate can always be used as an inverter. Inverter means NOT gate. If you will apply X over here and other input to be 1, control input to be 1, then you will get X XOR 1, and X XOR 1 is nothing but X bar. So here, if I'll take this input as a control input and I'll apply control input to be 1, this will invert the applied input X to X bar and it will work as an inverter. If I'll put this control input to be 0, then X XOR 0, it will produce output X, that is, it will work as a buffer. Input as it is passed at the output with some delay of this gate, that is called as buffer. Okay, so XOR and XNOR gate can be used as an inverter as well as used as a buffer, both circuits. And XOR and XNOR gate, this input, the 1 and 0, both are enable inputs, because when you apply 1, output is function of the remaining variable X. When you will put this input to be 0, output will be again X. Output is function of remaining variable X. At one time it is X bar, at one time it is X. So both 1 and 0 are enable input for XOR as well as XNOR gate. Okay, there is no disable input in case of XOR gate. So this is wrong option because it can be used as an inverter. It is not possible to use XOR gate as inverter. This is wrong. It can be used as an inverter. It is possible to use XOR gate as inverter. It is correct. So the option A, B, D are correct options. A, B, D are correct options. Okay, A, B, D are correct option. Okay, clear? चलो इसका आंसर बता दो, इसका आंसर बता दो. मेरा काउंटर गलत है क्या? काउंटर क्या काउंट कर रहे हो? कौन सी चीज काउंट हो रही है भाई? मुझे नहीं पता क्या काउंट कर रहे हो. The logic function implemented by 2:1 mux is A bar B bar plus AB, A bar B plus AB bar, A plus B bar. ये भी mux, ये भी वो क्वेश्चन आपका MSQ क्वेश्चन. यहाँ पे भाई ये हटा देते हैं ना, ये बस दिखाने का तरीका है ना, ये बबल है ना, कई बच्चे बबल समझ लेते हैं सर, ये हर जगह बबल लगा हुआ है, बबल नहीं है ना. अरे भाई काउंट कर लेना बाद में, अराउंड 20 या 20 प्लस क्वेश्चन ही होंगे, है ना. मेरे पास देखो कितने स्लाइड्स हैं. हाँ तो मेरे पास 3 यहाँ पे है ना. हाँ तो मेरे पास काफ़ी क्वेश्चंस है ना, तो टेंशन ना लो, है ना, टेंशन ना लो. सुपर 20 काउंट कर रहे हैं लोग. ठीक है, मैंने एक चीज बताई थी, अगर 2:1 मक्स आपको कभी दिखे, इफ यू सी अ 2:1 मक्स given to you, then always try to see I0 and I1. If I0 and I1 are complement of each other, then XOR or XNOR will be implemented for sure. If I0 and I1 are complement of each other. If I0 and I1 are not complement of each other, then any other function can be implemented. Then you need to find out by expanding it. Here I0 and I1 are complement of each other, and if non-complement is applied at I1, then this non-complement forms XNOR with the select input. Always XNOR, take XNOR with select input, and whatever select input is, select input can be applied with AB, है ना. I can take a AND gate and I can apply this AB over here, है ना. So always try to write down in terms of select input and then put the select input value. So if non-complement is I0, suppose this B is over here and this B bar is over here, then this non-complement forms XOR with S0. Okay, so this is B XNOR S0 and this B XNOR S0 is A. So this is A. So this is A XNOR B. And what is the SOP expression of A XNOR B is both complement are together and both non-complement are together. When you try to write down this in POS format, one complement and one non-complement in each bracket. So A bar, B bar, plus AB, this A option. A plus B bar into A bar plus B, this C option is correct. So both A and C options are correct. हाँ जी सर, अभी आई एम इन क्लास सुपर 20, बस 15 मिनट में फ्री होके करता हूँ आपको। शिवम सर के साथ एक सेशन शूट करना है, सर ने इसीलिए कॉल किया था, ठीक है। है ना, चलो रोहित बेटा, इजी क्वेश्चन भी करने पड़ते हैं कभी कभी, यही क्वेश्चन आप गलत करके आओगे ना। चलो रोहित के लिए हमने बनाया एक बढ़िया सा क्वेश्चन। रोहित नाउ सॉल्व दिस क्वेश्चन, है ना बेटा। कुछ लोग देखो आप, मैं जिंदगी का एक राज बताता हूं, देखो ये मैं हिंदी में बोल सकता हूं क्योंकि ये पढ़ाई से रिलेटेड नहीं है, ठीक है। एक राज बताता हूं कि कई बार कितना भी मिल जाए किसी को, वो बेचारा खुश ही नहीं हो पाता है ना, वो परेशान ही रहता है। बेटा गेट का जब पेपर आएगा, सो एवरी क्वेश्चन विल नॉट बी लाइक कि तुमको एक तुम्हारे ऊपर बुलेट फायर कर रहे होंगे गेट वाले। ऐसा क्वेश्चन दे दो रोहित हिला ही नहीं पाए, 10 मिनट का हर क्वेश्चन होना चाहिए। हर टाइप के क्वेश्चंस होंगे बेटा, और यही क्वेश्चंस तुम गलत करके आओगे, देखना। हो सकता है तुम टफ क्वेश्चन सॉल्व कर लो क्योंकि तुम एकदम दिमाग बैठाए हो, हर क्वेश्चन ही एकदम युद्ध की तरह होगा। हर तरह का पेपर आता है, बैलेंस पेपर आता है ना। तो बेटा हर तरह के क्वेश्चन यहाँ आए हैं, ऐसा नहीं होगा कि एवरी क्वेश्चन विल बी लाइक एकदम ऐसा बना दो कि हाँ भाई एकदम पढ़ने के बाद बच्चे का दिमाग वाग हिल गया, 50 के 50 क्वेश्चन ऐसे थे। गेट वाले एडमिशन लेना चाहते हैं आईआईटी में, है ना, ऐसा नहीं करना चाहते हैं कि 100 में से 10 मार्क्स आए टॉपर के, या 20 मार्क्स आए, या 25 मार्क्स आए। तो बेटा है ना, जब कुछ कराया जा रहा हो तो हमको भी आपसे ज्यादा एक्सपीरियंस है। कई लोग थोड़ा सा सब्जेक्ट सीख लेते हैं तो उनको लगता है अब हर क्वेश्चन वही दो सर एकदम टफ वाला होना चाहिए। बैलेंस तरीके से किया करो। इंपॉर्टेंट ये है कि जो क्वेश्चन कर रहे हो उसको कितना एनालाइज कर रहे हो, कितने ध्यान से कर रहे हो, तुम्हारी रीडिंग हैबिट कितनी सही, तुम्हारी एक्यूरेसी कितनी अच्छी है ना। अच्छे क्वेश्चंस भी मिलेंगे, ये देखो एक अच्छा क्वेश्चन है, निकालो थोड़ा सा, है ना। तो इतना परेशान नहीं होते हैं बेटा, है ना, हर तरह के क्वेश्चन कराए जाएंगे, है ना। कितना भी प्रोवाइड कर दो, ऐसा नहीं सर वैसा कर दो, ऐसा कर दो, बेटा ऐसे परेशान रहोगे तो जिंदगी भर परेशान रहोगे, है ना, परेशान ही रहोगे, है ना। तो ट्राई टू यूटिलाइज योर रिसोर्सेज व्हाट यू हैव, है ना। ऐसा होता तो अच्छा होता, वैसा होता तो ये होता, ऐसा नहीं होता तो ये होता, इसमें जिंदगी कट नहीं पाती है ना। चलिए इस क्वेश्चन को सॉल्व करिए। At output y, whatever waveform we will get, they ask you to find out the duty cycle of that waveform. Quickly consider the following circuit. Now let us try to find out what is y. Firstly calculate output y in terms of this q0 and q1, then try to draw the waveform, है ना। Initially firstly find out y, this is in terms of q0 and q1, and then try to solve the circuit. Okay, then try to solve the circuit. म्यूजिक वेनिस बेटा, म्यूजिशियन वेनिस, म्यूजिशियन विंस, क्या है ये, है ना। बेटा आप बच्चे तो वापस हो नहीं पाओगे, हाँ आगे थोड़ा बढ़ो लाइफ में, आपके बच्चे हो सकते हैं, ठीक है। तो उनको फिर जैसा तुम सोच रहे हो, जैसी जिंदगी की मैं काश बच्चा होता, उनको तुम वैसी जिंदगी देने की कोशिश करना। इसलिए पढ़ाई करो थोड़ा सा अच्छे से, है ना, कुछ जॉब वॉब लगे, है ना, फिर आपके भी बच्चे होंगे और बढ़िया से फिर जिंदगी कटेगी। उन बच्चों के साथ फिर ये बचपन जी लेना अपना, ठीक है। उन बच्चों के साथ, है ना। मेरी 2 बच्चियां हैं, मुझे बहुत अच्छा लगता है उनके साथ टाइम स्पेंड करना, बहुत ही ज़्यादा, मतलब एकदम सबसे, मतलब पूरे दिन भर में जो सबसे अच्छा टाइम होता है जो उनके साथ होता है, लिटरली, मतलब इसमें कोई डाउट ही नहीं है। उनके साथ 1 घंटे बिता लो तो लगता है क्या ही, कितना ही आनंद आ गया, है ना। ठीक है, तो बेटा आगे का सोचो, है ना, जो चीज़ वापस नहीं आ सकती उसके बारे में नहीं सोचना है। ठीक है, चलो पहले y फाइंड आउट करो, ट्राई टू फाइंड आउट y। ठीक है, चलिए यहां देखो क्या है, ये Q नॉट बार है। पहले देखते हैं y निकाल तो लेते हैं, फिर ड्यूटी साइकिल निकालेंगे। Q नॉट और Q1 के टर्म में y है क्या, फिर हम Q नॉट और Q1 को सॉल्व करेंगे और उसी से निकाल लेंगे यार। ये देखो क्या आ रहा है, यहां से देखो क्या आ रहा है, यही सेम क्लॉक लगी हुई है यहाँ पे, ठीक है ना। तो कुछ ज़्यादा ही कॉम्प्लेक्स क्वेश्चन नहीं बना दिया हमारे भाइयों ने, चलिए कोई बात नहीं, हम तो सॉल्व ही कर देंगे। तो ये क्लॉक आई है, तो यहाँ से क्लॉक आ रही है, ठीक है भाई साहब, है ना। सो Q1 इंटू क्लॉक यहाँ आ गया भाई साहब, यही है ना। तो ये क्लॉक यहाँ पे भी कर रही है, यहाँ पे भी कर रही है, यहाँ Q1 है, तो यहाँ आ गया Q1 इंटू क्लॉक, और यहाँ Q नॉट बार आ रहा है। तो y इज Q नॉट बार इंटू Q1 इंटू क्लॉक, यही तो आ रहा है। मतलब हमें अगर Q नॉट की वेव फॉर्म पता हो, Q नॉट की पता होगी तो Q नॉट बार की पता ही होगी, Q1 की पता हो, और क्लॉक तो हमारी स्क्वायर वेव फॉर्म होती है, तो हम पता कर सकते हैं। यहां देखो Q नॉट यहाँ पे आ रहा है, ये 0 है। 0 के लिए XNOR गेट क्या बनाता है, इन्वर्टिंग बफर की बफर, इन्वर्टिंग बफर, तो ये पास करेगा Q नॉट बार। अब बेटा दोनों फ्लिप फ्लॉप की कैरेक्टरिस्टिक इक्वेशन, लेट अस राइट डाउन द कैरेक्टरिस्टिक इक्वेशन। Q naught n plus 1 is nothing but going to be D, and D is driven by present output Q naught bar n. तो ये toggle mode में, it is operating in toggle mode. At every trigger it will be toggle, it will toggle from 0 to 1 or 1 to 0, and this is already in toggle mode, because for T input to be 1, Q1 n plus 1 is going to be T XOR Qn. So this is going to be 1 XOR Qn, which is again going to be Q bar n, Q1 bar n. Okay, so both are operating in toggle mode. Let us try to plot the waveform. Let us try to plot the waveform. Let us take clock, because clock is triggering both the flip flops at the same time. Okay. Okay, so this is negative S trigger. Both the flip flops are negative S triggered and triggered by the same clock. So this is negative S, this is second negative S, this is third, this is fourth. Okay, starting in starting, both Q1 and Q2 are 0 0, both are 0 0. At this trigger, Q1 will go from 0 to 1, and Q naught will also toggle from 0 to 1. At next trigger, it will toggle from 1 to 0, and then again 1 to 0 and 0 to 1. So this is Q1. Okay, and this is Q naught. Q naught is same as Q1. Why, sir? Because it is also toggling with the same trigger. So at this trigger, it will toggle from 0 to 1. At this trigger, it will toggle from 1 to 0. At this trigger, it will toggle from 0 to 1. So you can say that from this finding, this is clock, Q1 and Q naught are same. Q1 is equal to Q naught at every instant. So what will happen if Q naught and Q1 are always same? So I can replace this Q naught bar from Q1 bar, and this is Q1 bar into Q1 into clock will always be 0 irrespective of the clock, because Q1 bar into Q1 is 0. And if Y is always 0, its duty cycle will definitely be 0, because Y is a DC value. Y is 0 means 0, logic 0 is plotted by 0 volt, है ना. So waveform of Y will be constant. Y will be 0 only. Y is 0 always. Duty cycle will be 0% because it is a DC value. You can calculate the duty cycle in case of square waveform. In case of square waveform, not 50%, not 25%, beta, है ना. At same trigger, both are toggling. Both are initially at 0 0, and both are toggling 0 to 1, 1 to 0. So both are same actually. both waveform Q1 and Q0 are same, and as this is Q0 bar into Q1 into clock, so Q0 is same, so Q0 can be replaced by Q1 bar into Q1. It is always 0. So duty cycle is going to be 0%. Okay. So answer 0 bhi aa sakta hai. Okay. So if it is a DC value, suppose if you get the output Y to be 1, always independent of clock, so 1 Y is equal to 1 is plotted like 5 volt, always 5 volt, logic 1, always 1. It is not changing, it is not oscillating between 1 and 0. How you calculate the duty cycle? T on upon T on plus T off multiplied by 100. Okay. Okay. And in case of DC signal, the time period is infinity. It will oscillate at infinity. So duty cycle is nothing but T on upon time period T multiplied by 100%. And in case of DC signal, when Y is fixed at 0, it is a DC value, DC signal. If Y is 1, it is fixed at 5 volt, it is a DC value. So if Y is fixed at 0 or 1, duty cycle is going to be 0. Why? Because time period T is going to be infinity, T on plus T off. Because DC signal repeats at T is equal to infinity. So this is infinity, then duty cycle will always come out to be 0%, always 0. क्लियर है? क्लियर हो गया? क्लियर? गॉट माई पॉइंट? ओके. रोहित बेटा खुश? खुश तो बहुत हो गए तुम, है ना? खुश तो बहुत हो गए तुम. इस तरह 20 क्वेश्चन हो चुके होंगे. अब मैं एक या दो क्वेश्चन आपको होमवर्क के लिए दे देता हूं. आप टेलीग्राम चैनल ग्रुप में यू कैन डिस्कस इट विद मी. ये बहुत अच्छा क्वेश्चन है. 1 क्वेश्चन इज फॉर होमवर्क, योर होमवर्क. ओके, या करा दूं? एक आसान क्वेश्चन होमवर्क के लिए दे देता हूं. ये वाला करा देता हूं, मक्स वाला करा देता हूं, है ना? मक्स वाला करा देता हूं, मक्स वाला नहीं, ये होमवर्क के लिए, है ना? बस बाकी क्वेश्चन वी हैव ऑलरेडी डिस्कस. ये वाला कर लो. दिस इज अ वेरी गुड क्वेश्चन. रोहित, अच्छा क्वेश्चन है भाई, सॉल्व करना है आपको. चलिए इस क्वेश्चन को सॉल्व करिए. दिस इज द लास्ट क्वेश्चन. At 7 p.m. we'll meet at गेट वाला EEC चैनल फॉर महाअभ्यास सेशन, है ना? सो रोहित भाई आ जाना वहां पे, और टफ क्वेश्चन हम डिस्कस करेंगे. ठीक है? लास्ट क्वेश्चन फॉर टुडेज सेशन, है ना? The design of a combinational circuit is attempted as demonstrated below. For S to be 0, Y is 0 regardless of status of B. For S to be 1 and B to be 0, Y should be X1. For S to be 1, and B to be 1, Y should be X0. The minimum number of count of 3 input NAND gates required to complete the design will be. So this combinational circuit needs to be designed using 3 input NAND gates, and how many minimum number of NAND gates required? You need to find it out. Very good question. Very, very good question. Two. How the answer is 2? ध्यान से करा करिए भाई, ध्यान से. Let us write down the output Y. How many of you are able to write out the how many of you are able to write down the output Y? This is the main question. If you are able to write down the output Y in terms of X1, X0, S and B, then you will be able to solve this question. Okay. Firstly, try to write down the output Y in terms of, this is also selection input is also input line, and these two are input lines. On the basis of values of S and B, input line X1, X0, they are transferred to the output Y. So try to write down the Y on the basis of values of S and B, whatever information is provided. हाँ 3 से 4 मिनट लगेगा. Firstly write down the answer. ध्यान से करिए. Now firstly they have given that yes अगर 0 हो गया, if yes is 0, y is 0 regardless of status of B. Regardless of status of B means what? Yes is 0, B could be 0 and B could be 1 regardless of B. Means yes 0, B 0, yes 0, B 1, y is 0. That is what? Because yes and B can together take 4 possible values, 0 0 0 1, and for 1 0 and 1 1 they have given what should be y. So there are 4 possible values of S and B. So this information contains 2 possible values, and other 2 possible values are over here. So total 4 possible combination of S and B are possible. So for S to be 0 and B to be 0, y is 0 into, at y you are transferring 0. They have said that y is 0 into 0, or S is 0, B is 1, output is again 0. Because if S is 0, regardless of the value of B to be 0 or B to be 1, y should be 0. Or when S is 1 and B is 0, when S is 1 and B is 0, y is x1 into x1. Or when S is 1, B is 1, y is x0. What? So y is basically SB bar x1 plus SB x0. So this y is given in SOP format, and that is required for finding out the minimum number of NAND gates. So firstly you need to find out y, that is SB bar x1 plus SB x0. It cannot be further simplified. Whether simplification is possible? No sir. Only I can take S to be common, B bar x1 plus B x0. It cannot be further simplified. And here no hidden NAND is there. Why sir? Here no hidden NAND is there. Because only one variable is in the form of complement B bar. You must have at least 2 variables in complemented form for hidden NAND to be there. So directly we will be finding out y bar. So when I'll take whole complement, I'll be getting SB bar x1 whole bar into SB x0 whole bar. Now we have 3 input NAND gates, not 2 input. They have said that 3 input NAND gates are required to complete. So we have available with 3 input NAND gates. So to generate this output, I'll apply S, I'll apply B bar, and I'll apply x1. Then I'll get S into B bar into x1 whole bar. So I need to generate B bar also, because B bar is not available at all. Until and unless it is said in the question that B bar is available, you will not take that B bar is available until unless it is mentioned. So to generate this function, one NAND gate is required where you will apply S, B bar and x1, you will get S into B bar into x1 whole bar. And for generating B bar, one 3 input NAND gate is also required. Why sir? Because I'll apply B, all the input to be B, I'll be getting B into B whole bar, that is B bar. Okay, so for this I'll be requiring 2 NAND gate, because one for B bar and one for S into B bar into x1 whole bar. I'll be requiring only one NAND gate, one 3 input NAND gate to generate this function. I'll apply S, B and x0. I'll be getting S into B into x0 whole bar. So y bar is equal to nothing but P, this is P and this is Q. So y will be P into Q whole bar. I have generated P using 2 NAND gate. I have generated Q using 1 NAND gate. But I need to, for generating y, I need to generate P into Q whole bar, and for that I require 1 NAND gate. How sir? I'll be using 3 input NAND gate. Either I'll apply Q and Q together, either third input I can take 1, because 1 is always available. P into Q into 1 whole bar is P into Q whole bar, or P into Q whole bar is P into Q whole bar, because Q into Q is Q only. Yeah, P into P and P can be tied together. So this is P into Q whole bar is P into Q whole bar. So 1 NAND gate here, 2 NAND gate here, 1 NAND gate here. So I'll be requiring 4 3 input NAND gates to design this circuit. So 4 is the right answer. If B bar is available, then 3 NAND gates will be required. Okay, getting my point or not? Getting my point or not, बच्चा लोग? Okay. So revise the theory and come at 7 p.m. होमवर्क में प्रैक्टिस पीवाईक्यूज बहुत इंपॉर्टेंट है ना। और जो लोग भैया 2027 या 2028 के इस सेशन में, इफ एनीबडी इज हियर फॉर 2027 और 2028, so you can go and use this code for getting the course. You will get 1000 extra off. Okay. क्लियर? हाँ, यूनिक में डिफरेंट क्वेश्चन होंगे बेटा, श्योर। ये क्वेश्चन क्यों रिपीट करूंगा यार? So there are 25, around 25 different question in the unique session, and those questions are on a little bit tougher side compared to the question in this session. Okay, some basics and very tricky questions are there, some very fundamental questions are also there, and some very tough kind of questions are also there in that session in Mahabhyas. Okay, at 7 p.m. So don't miss that session. Okay, please don't miss that session. Okay, we'll be solving some very beautiful question है ना in the evening session at 7 p.m. That session is at Gate Wallah EEC channel. Okay, and that session is for CS students also, for ECE students also, for EE students also, for IN students also. Okay, so मिलते हैं फिर at 7 p.m. at Gate Wallah EEC channel with महाअभ्यास session. Thank you so much everyone. जितने भी क्वेश्चन कराएं जो आपने बहुत अच्छे से कर लिए, बहुत अच्छी बात है। जिन क्वेश्चंस में आप फंसे हो उनको जाके फिर से देखना, फिर से रिवाइज करना और एनालाइज करके उसको सॉल्व करने की कोशिश करना। इन लास्ट टाइम आपको यही करना है, अपनी एनालिसिस को अच्छा करना है ना, एनालिटिकल एबिलिटी को अच्छा करना है, अपने गलतियों को कम करना है, अपने आप को इंप्रूव करना है जितना आप कर सकते हो। ठीक है, तो मिलते हैं 7 बजे गेट वाला EEC चैनल पे। थैंक यू सो मच एवरीवन, बाय बाय। ठीक है, बेटा ये पीडीएफ मैं अभी शेयर कर दूंगा है ना। आई विल शेयर दिस पीडीएफ इन टेलीग्राम चैनल ग्रुप है ना। तो जो भी क्वेश्चन होमवर्क वाले हैं वो मिल जाएंगे और जो क्वेश्चन आपने सॉल्व किए वो भी मिल जाएंगे। ठीक है, सो आई विल शेयर दिस पीडीएफ इन द टेलीग्राम चैनल ग्रुप।